any quadratic equation, ax squared plus bx plus c equals 0, where the solutions, the roots are x1 and x2, x1 plus x2, so the sum of the roots, is equal to minus b over a, and x1 times x2, that is the product of the roots, is equal to c over a. If you compare that back to what we saw in the get ready, we saw that that worked for each of those four things. Now let's have a look at the proof of this particular result. So we have a quadratic, ax squared plus bx plus c equals 0, quadratic equation, have roots x1 and x2. So that's just saying the start of this theorem. So we know we can write this in the form a x minus x1 times x minus x2. That is factorized form or root form, depending on where we're using it. And we know we can write the quadratic like that because we know the roots. Expanding this gives us, we get x squared, then we get x times by x1 minus x times by x2 plus x1, x2. A little bit of factorization in the middle here, we get x squared minus x1 plus x2 times by x plus x1, x2. And then multiplying through by the a in the expansion, we get ax squared minus a x1 plus x2 times by x plus a x1 x2 is equal to 0. We can equate this to the original equation, that is ax squared plus bx plus c. That means that a must be equal to a x plus 1x squared must be equal to b, and a x1 x2 must be equal to c. So those things sort of put down together, we have minus a x1 plus x2 has to be equal to b, and we also have that a x1 x2 has to be equal to c. Dividing through, x1 plus x2 must be equal to minus b over a, and x1 times by x2 must be equal to c over a. And we have proven the result that if the roots are x1 and x2, then the sum of the roots must be minus b over a, and the product of the roots must be c over a.